The security camera that you install today may still be operating in 2031. The access control panel that you specify this year, it may just remain connected to your network for the next decade. That OT that's keeping a facility running may still be in service long after that. But here is the question that very few security leaders are still asking. Will the cryptography protecting those systems last as long as the systems themselves? Because a device can still work perfectly while the trust protecting that device becomes obsolete. And President Trump's new post-quantum cryptography mandate, it just moved that conversation from being a future technology concern to now being a present-day security, a present-day procurement, a present-day life cycle decision. And this is not just a cyber story. No, this is a IT story. This is a OT story. This is a AI story. But there is one part of the technology ecosystem that I believe is being overlooked. Any guesses? What do you think? Physical security. The cameras, the access control systems, the credentials, the sensors, the video platforms, the intelligent edge devices that may remain installed way after the cryptography that they were initially designed to use begins reaching the end of its useful life. And so today we are asking a much bigger question. That question is this: what happens when the operational life of security technology becomes longer than the security life of the trust that is protecting it? I want to welcome you to SecuriTea, the thought leadership podcast where security leaders unpack the forces that are reshaping AI, reshaping cybersecurity and physical security, IT and OT, IoT, and then leave with decisions that they can then act on. And so today we are unpacking President Trump's executive order that is securing the nation against advanced cryptographic attacks. And so our job is not to turn this into a political conversation. Our job is to separate the policy from the politics, separate the signal from the noise. And so with that comes the understanding of what that means for technologies that are protecting people, that are protecting facilities and information and operations and critical infrastructure. And so with that being said, let's pour the tea. Literally, that was just an excuse for me to actually take a sip. So, what happened? On June the 22nd, 2026, that is when President Trump signed Executive Order 14412. I'll put it in the notes. That order accelerates the federal government's migration to post-quantum cryptography, commonly shortened to PQC. PQC. We can make a beat out of that. Anyways, at the center of the order is the concern that a sufficiently powerful quantum computer could perhaps eventually compromise some of the public key cryptography that is widely used today. And so that cryptography helps systems establish secure connections. It helps authenticate devices. It helps support digital certificates. It helps verify software and firmware. And it helps determine whether another device, another application, another user can actually be trusted. The order establishes federal milestones that go along the way. High-value federal assets and high-impact systems are directed to transition PQC for key establishments by the end of 2030, 3.5 years. Those systems are then going to be directed to transition to the post-quantum digital signatures by the end of 2031. And so the order also directs agencies to go on to appoint migration leaders, conduct pilots to support critical infrastructure planning, and prepare future requirements for certain federal contractors. And just 2 days later, after that June 22, Yes, June 22nd, just 2 days later after that, the Office of Management and Budget then went on to release an implementation guidance. The early work is not the mass replacement here. It is the discovery. It is the inventory, the risk assessment, the governance. It's the vendor coordination. It's the migration planning. And that sequence itself, it matters because you cannot migrate cryptography that you cannot find. And this is where the physical security industry should be paying attention right here. Because a modern security system is no longer a collection of just isolated devices. No, I've been championing this. A camera may use certificates to identify itself. An access control panel may connect to cloud services. A mobile credential may depend on public key infrastructure. A sensor that's out there, it may receive signed firmware updates. And AI, well, sheesh. AI-enabled edge devices may receive new models after the installation. And so the customer sees a camera, the customer sees a reader, a controller, a sensor, but underneath of that is a product with a chain of trust. And post-quantum cryptography matters because some public key algorithms that are used today may eventually be vulnerable to sufficiently capable quantum computers. Now, as of this recording, there is no publicly known quantum computer that can currently go out there and perform that attack at the necessary scale. But security planning is not only about the threats that became operational yesterday. It is also, in addition to, about how long that information must be and remain protected. One concern that is often described as harvest now and decrypt later. This is where an adversary could collect encrypted information today, and then store that information with an attempt to decrypt it later on in the future when there has become more capable technology in order to decrypt it. And so that creates 3 different timelines for security leaders. Number 1, the first one is how long must the information actually remain protected? IT auditing. How long will migration take? All right, I'm seeing ISO here. And when could that threat become practical? Now, we can't go out there and we can't guarantee a date for that third question. It's not possible. But we know some of the information that must remain sensitive for years. So think about this. Think about biometrics. Think about access histories, the critical infrastructure designs, the facility layouts, the investigations, the sensitive video, the identity records, and operational data. And we know that large technology migrations, they can take years. But that is why planning begins before the threat becomes fully operational. See, now we bring this directly into physical security because the useful life of a device is not always the same as the useful life of its cryptography. And so a camera could go on and it could continue producing a clear image while the cryptography that's supporting it and supporting its identity, supporting its communications and the firmware and the integrations, all of those things that are around it become outdated. An access control panel, it could continue opening doors while its upgrade path becomes increasingly difficult. And so a connected sensor, it could remain operational while the manufacturer no longer supports the cryptographic components that is actually dependent upon it. So the technology can remain functional, but the trust architecture that is underneath of it, well, it ages. And so that may create a new form of end of life. Not hardware end of life, not software end of life. Cryptographic end of life. For years, the physical security procurement they have focused on image quality. They have focused on storage. They have focused on integrations. They have focused on analytics and warranty and price and all those things. Those are not bad things. Those questions, they absolutely matter. But we may need to add another. I propose that we may need to have a product that remains trustworthy for as long as we can expect it to remain operational. So the OMB guidance that already points towards this convergence, they're already pointing towards it. It notes that the federal work testing post-quantum ready physical and logical access systems. Physical access is already inside federal implementation planning. And why would it not be? It's been for years, but now we got some documentation that is going behind it. And so for these manufacturers, the first issue here is visibility. Where does cryptography exist inside the product? Is it used in device certificates? Is it used within the secure communications, within the firmware? Is it used within the validation process and cloud connections and mobile applications and APIs and identity service, on and on and on, those third-party libraries that people love to use? The executive order, it also calls for guidance around cryptographic bill of materials. Now, a software bill of materials, it helps identify software components. A cryptographic bill of material, well, that goes even deeper. See, what algorithms are actually being used? Where are they used at? What's the function that they need to be able to perform? Can those actually be changed? Can customers evaluate migration risk when the cryptography inside of a product seems to be invisible? And so the next manufacturer issue is agility. Can a new cryptographic capability be delivered through firmware? Does the hardware have enough processing power? Does it have enough memory? Will the larger keys of signatures affect the actual performance? Will the integrations still work? Will some of the product generations require a replacement? You see, customers do not need manufacturers to pretend that every product can support every future requirement. We do need to be clear on roadmaps. We do need to be clear on what can migrate. We do need to be clear on what cannot be migrated. What requires new hardware and how long will it reach the product family and remain supported? See, after that, there is the installed base. How many products can be deployed today and still be operating in 2030 and 2031 when these things start to hit? Which can receive the updates, which depend on unsupported libraries, which may need replacement before the hardware physically fails. That is a product issue, a capital planning issue, and a customer trust issue. Now we bring AI into this conversation, and physical security devices are becoming even more intelligent. Analytics are moving to the edge, and AI can reduce the noise. It can identify patterns. It can prioritize events. It could accelerate investigations. But AI does not reduce the need for trust. AI multiplies the number of trust decisions that are happening on a machine speed. It is creating more decisions to be made. A camera captures the information, an AI model then goes on to interpret it. See, the system, it creates the event, and that event then travels across a network. A platform then goes on to receive it, then you got the operator sitting on the other side of the desk, and it sees a prioritized alert. Bam, there goes another system. Another system initiates another workflow. And every step, we depend on trust. Is this a authorized device? Is it actually running authenticated firmware? Is the AI model legitimate? What was the data that actually changed? And did the alert come from the expected system? Post-quantum cryptography, PQC, does not have and solve every AI problem. It does not eliminate or guarantee accurate detections. But cryptography helps support the identities. It helps supports the signatures. It helps supports the certificates. And it helps secure communications inside the trust chain. The more consequential the AI-driven decisions, the more important the integrity of the systems that is actually supporting. So with that being said, now let's talk about integrators. We talked about manufacturers. Let's talk about integrators now, because integrators are in a unique position because they understand the actual environment. They know what is being installed. Integrators know which systems are old. They know how cameras, the access control, the networks, the cloud platforms, the operational workflows. They know how all those things connect. The integrator of the future. Me and Antoinette King was talking about the 21st century integrator. Anyways, so the integrator of the future, it may not integrate just devices. They may also integrate, and the integrator may help customers manage the life cycle of trust. That could include asset inventory. It could include firmware. It could include certificate visibility. It could include lifecycle assessments. It could include migration planning and coordination across manufacturers and IT and cyber and physical security and operations. You see, integrators do not need to become cryptographers. Integrators may need to become better translators. Cyber may own cryptographic policy. IT may own certificates and network. Physical security may own devices. OT may own availability. Manufacturers, they may own product architecture. Procurement may own the contracts, but nobody owns the entire chain. The organizations that have the ability and can map dependencies can coordinate the change. They may become even more valuable. So what should security leaders do right now? First thing you should do right now, do not panic. Do not replace every connected device. Do not buy the first product carrying a quantum safe label. Start with these 5 questions. First, trace the trust chain. Choose just one critical physical security system and map its devices. Map the certificates, the software, the cloud services, map the firmware, the processes, the AI models, map the operational dependencies. The second, rank by consequence and by the lifespan. How long will the system remain installed? How long must the information remain protected? And what happens if device identity? What happens if firmware integrity or secure communications fails? What happens in those scenarios? Third, understand the upgrade path. I want you to ask manufacturers what can change through firmware. What requires new firmware? Which product generations will actually be supported? And how? How updates are going to be authenticated. The fourth thing is to specify the agility and the evidence. I do not want you to ask whether a product uses encryption. I do want you to ask whether its cryptography can actually evolve and what evidence supports the future readiness of their claims. The fifth one is to test the whole ecosystem. Test the device, test the network, test the certificates, test the applications, the cloud connections, the integrations, the AI workflow, test the performance, test the operational impact. Because here is the signal beneath the noise. President Trump's post-quantum mandate is not only a story about quantum computing, it is a story about the future of trust. For years, convergence meant connecting physical security systems to IT networks. As Antoinette King put it, convergence 1.0. But that definition is no longer convergence. Convergence is increasingly means that systems are sharing identities, systems are sharing data, and systems are sharing cloud platforms, systems are sharing intelligence and workflows in a common trust architecture. You know, a camera depends on a network. The network depends on identities and certificates. Devices depends on trusted firmware. The AI depends on trusted software and trusted data. The operational environment depends on those systems actually remaining available. But a failure of trust in just one layer, it can become a cyber risk. It can become a physical security risk. It can become an AI assurance risk, a IT risk, a IoT risk, a OT risk, and ultimately it becomes a business risk. So before your next deployment, ask one question. Ask this: will the trust protecting the system last as long as the system itself? Because your security technology does not need to stop working to become a liability. It may continue operating exactly as designed while the trust beneath it quietly creeps and becomes the end of its useful life. Organizations that prepare will be the ones that understand what they know. They will understand what they have. They will be able to demand transparency. They will be able to design for change. They will be able to manage trust as a life cycle. This is SecuriTea, where we unpack the forces that are reshaping IT, OT, AI, physical security, and turning them into decisions that security leaders can act on. Until next time, keep asking the questions the industry has not started asking yet, and I'll bring the receipts.